I have constructed a Magneto-Dynamic Infundibulator. Uh, I have. I really have. I have constructed a Magneto-Dynamic Infundibulator. Now, I should explain that a little bit. I constructed it, or specifically two of them for stereo purposes, out of little electronic parts like these. It's not a plug-in. It is a hardware project. And it's not a joke. This is a real thing. But it is not the model. This is, of course, based on concepts from the Giraffe Audio, think G21, Magneto-Dynamic Infundibulum. So what I have made is not an infundibulum. Those will set you back more than $3,000. I would love to have some. Join my Patreon and I'll try to get one. But it would have to be going really well for me to be able to get one because they're very fancy devices. But as it happens, it's possible to use the same principle at a much lower cost point. And here's what it does. It's a new piece of music. And we'll skip ahead. Now that might not be all that exciting all by itself. What the Magneto-Dynamic Infundibulator can do is compared by this. This part is a regular XLR cable, and this is the Magneto-Dynamic Infundibulator, and both are normalized. So we go from a level of this. It's an analog mix, and we're normalizing across the entire mix to this. The Giraffe Audio piece is known for being able to do stuff like this. What I've done with the Magneto-Dynamic Infundibulator is come up with a way of getting effects in the same general theme, in the same general theory, without costing you more than $3,000. Now, what I can make, or what you will make, because I'm going to show you how to do it, is not mastering grade, it's not balanced in the same way, it's not calibrated to that kind of a high level, and you're going to have to make it yourself. I'm not going to make these for you. But it is well worth doing. Now I'm going to have to explain a number of things about transformers and things you can do with them. So bear with me. But first, it might be worth taking this. This allowed me 7.31 dB of gain, largely because this spike here, whatever it was, which is also shown here, was way beyond everything else. But it's only fair to do a level match comparison. So what we'll do before getting into the details of the transformer and how I built this thing is a little bit of listening, and bear with me on the music. The name of this song is Science Experiment, and this very much is. You should be able to hear what it sounds like in level matched form to get a sense of how this thing works. Because the way that it works is it suppresses more and more of this kind of nasty spiky energy and reshapes the waves drastically. So yeah, like here is the beginning, which is a number of things going on there. That's not an electronic kick. That is the the ghetto sub kick that I built. That I have another video on how to make that. Now here is the Infundibulator. I'll go back and forth a little bit. No Infundibulator. By the way, I require that it be pronounced Infundibulator. It reminds me of Marvin the Martian or something like that, and I think it's in the spirit of the original concept, which I adore, that somebody built a device that's entirely passive, just as mine is, and decided to call it the Magneto-Dynamic Infundibulum. So this must be called the Infundibulator. I'll continue. How about over here? There's a spot. This is without Infundibulator. And then when we kick it in, it's stepping on transients quite hard, but in a rather special way. Let's see if I can find a place with this hi-hat. There's an overdubbed hi-hat in here. There we go. So that's good and loud. That's probably causing the transient spike there. And then when we go to the Infundibulator, gotta love analog gear for some of this stuff. It's really quite impressive. Here's what we're doing. The Infundibulator is done by basically misusing a transformer. Here is a transformer. This is nothing but a little coupling transformer. It is 3 different windings. All of them are about 600 ohms. Now this is larger than the transformer I used for my Infundibulator. So I had to and started working with them. I have a suspicion that using smaller transformers will cause it to kick in faster and have a more aggressive effect, but it's not what you might expect from a transformer. See, when you're using a transformer, we've got these connections here. And something I can do is whip out this old multimeter. This must be 30 years old. That doesn't really work, but it works well enough that you can probably hear that. And we can tell which connections are being made and which are not. Like that one, but we're not connected to this or this. Essentially, these connections are all going straight across. And I can draw that here. I'm about to show you a way where you can do this without actually having a multimeter, even a broken one like mine. But the way the connections go is like this. That's where these transformer windings, and you can see them inside here. They're the twists of wire there. They're wired straight across like that. So the loops of wire start at one side and go straight across to the other. Now, it's possible to also do things using center tap transformers and stuff. I just don't have a center tap transformer. Now, what you would do if you don't have a multimeter is perhaps something like this. You grab a little amplifier, and behind me I have a guitar. And the thing about it is, don't mind me while I shuffle cables, that's just part of what I'm going to have to do. You can hold cables and sort of touch them together. Let's make that louder. Now notice the ground is only being connected by my fingers, but it'll still do enough that you can hear something's there. So if you were to strum the guitar and then touch it to the transformer, you can hear what's a connection and what's not. And if you go straight across like this, there's no connection there, so you don't hear anything. Oh. Wires, cables, oh noes. As long as I don't break the one that I'm trying to talk through, everything will be fine. Now, how do we get 7 dB or more of, and it could be more because I wasn't really pushing it all that hard, very clean gain and transient absorption out of a little piece of junk transformer like this? And notably, why would you run your entire mix through something that's this bad? Because this is a bad little transformer. Normally the way you do that, normally the way you run a transformer is by running your signal, and I'm taking a balanced out. The Magneto-Dynamic Infundibulator needs to use a balanced output, so I would advise using that on a line level, pro level balanced output. It's going to prefer the additional voltage that you give it, and that will just help it work better. Normally what you would do is do the plus to one side of a coil, the minus to another side of a coil, and then you'd take your output off of one of the other windings, and you'd use the transformer the way it's meant to be used, coupling two signals together with the transformer's inductance. Now here's what inductance is, and I'll get into all the details here. When you run a coil of wire and you feed energy into it, you can communicate waveforms through it in this way. But when you have the coil of wire in some kind of core, like a steel core like this is, or an iron core or something like that, it forms a thing called an inductor. An inductor is the opposite of a capacitor for audio purposes. If you have a capacitor to ground, it will let high frequencies through and obstruct low frequencies. Now, if you have an inductor to ground, it will let all the low frequencies through, but it will tend to obstruct high frequencies. So you could run an inductor to ground, and what would be allowed to continue going through the circuit would be the high stuff. Now, the way a Magneto-Dynamic Infundibulator, the way this device works is as follows. The Giraffe audio unit is known to use one transformer for both input and output. What that means is a infundibulator does not run plus and minus across a coil. It has plus and minus going along a coil. And your input would be here, and then your output would be here. You're just running the entire signal through the wires of the transformer. It's not actually transforming anymore. It's just a really long string of wire for both of your channels. Not only that, there is another factor, and this whole thing depends upon the fact that we've got balanced signal. If you are running through the wires in this way, you could run it so that the plus goes from here to here and the minus goes from here to here, or plus goes from here to here and the minus goes from there to there. Like the plus could be going this way and the minus could be going this way to get to the output. Choose wisely, because this will have everything to do with how well your infibulator works. The thing is, I can't tell you how your transformer is wired. This is how it worked for mine. You wire one side of it one way, and then try both wirings on the other one. You solder it and unsolder it and so on. One of those connections is going to be much, much higher gain than the other. Now, my assumption is this. The one that's not higher gain, and in my case it was this one going up and then that one going down. I was putting the inputs to these two pins. It was much lower gain because it was trying to drive the transformer, set up the sort of rotary motion of magnetic flux both directions at once. In short, I had wired the transformer so that it canceled out, and it was kind of resisting what it was doing. Now, when I wired it with both minus and plus down on one side and then the outputs on the other, it was significantly louder. And my assumption there is that both of the signals, the minus and the plus of the balanced output, were driving it in the same direction, and the transformer was driven in such a way that this third one, you could take an output off of that because it was being driven by balanced wires, not just a single coil, but two coils, and they were both in tandem. They were both kind of driving the transformer the same way. And that's why that orientation of the wirings was much louder. Here's where it gets interesting. And I think maybe I will take this piece of paper and use it to draw things on. So your transformer might look something like this. What you can do is start by wiring the ones you're running through with these little diodes. And I think actually I may have that wrong. Hang on. You might end up with something like this, where you are going in the input and your coils are going through here, and then there's your output, and that's going to the XLR cable on the way out. This is not so unlike a stomp box, which is wired like this. If you have a diode-based distortion box, those are made in this way. You have the signal here, and then ground here. And the way diodes work, it takes a little bit to get them going. Diodes are a thing where if the signal is negative, one of the diodes will not connect and the other one will. And it's supposed to let signal through to ground when it's the right orientation. Whether it's minus or plus, a single diode will basically stop voltage in one direction and allow it in the other. But it doesn't instantly kick in when you're allowing the voltage. So what you get is a signal like this where the voltage will rise, and then this is the point that the diode kicks in, and from that point onwards, anything beyond that just goes to ground. It just stops it at that point. So what you get is an output here. And then when you have two of them wired like this, one going this way and one going that way, you get distortion, because it can only put an output when it hasn't actuated either of the diodes to bleed the energy off. That's how diodes work. So what happens when you wire it like this across two transformer windings? Well, one thing that's happening is there's only one of them. That's how I've got my infundibulator. That's how I have my device wired. Now I could put the diode distortion circuit there, but I just tried this and I started getting very interesting results. All of the strange little strips of paper, but it's good for drawing waveforms. I would send in a sine wave, kind of like that, and wiring it in this configuration. And remember, there are long wires that are just going from this point to this point, and they are the windings of the transformer. Basically, I can just run signal through here because it's nothing but a wire. I'm using the coil. It's about, I don't know how many ohms, about 600 ohms of impedance. This is a telephone coupling transformer. And my diode is going across. So the diode is going from the end of this transformer coupling to the beginning of this transformer coupling, which is also inverted because it's the other side of the channel, and vice versa. It's this little crossover-y thing. And it would do this crazy thing. It would do this. I'm not sure what orientation I'm going to be using, but it would start here and give me a big peak and then cut it right back, and then swing over to another peak and then cut that right back. But wait, there's more. If you want to make a proper infibulator, Magneto-Dynamic, I keep wanting to say indefibrillator, crazy device with diodes and a transformer. How's that? We have a whole other coil here. We're running the whole signal through this, but there's this other coil that's not connected to anything. If I short it, it will change the induction characteristics of the transformer radically. It will cause it to resonate more easily, be kind of less obstructed. And here's what the Giraffe audio unit does. It's using additional windings, and it's adding stuff like, for instance, the Giraffe audio one also runs all of its special characteristics in parallel. So it's basically taking one probably good powerful transformer tap and doing a bunch of stuff to alter the way that it engages with the magnetic field. Here's one. You can put a simple distortion box wiring across this. You can also put a capacitor across that. Capacitor is drawn like this. That's not a very good capacitor. I'll try to clean it up a little bit. The two little lines there. And a capacitor, like you remember, lets high frequencies through. So what we're doing if we have a capacitor on there is telling the transformer winding, say we'll call it this one up in the top. If you've got a capacitor across there, you're saying, okay, reduce the amount that you're getting in the way of the magnetic flux a lot once the frequency is high enough. If the frequency is not high enough, you'll be obstructed and you'll get in the way. If you have the diodes, what you're saying is, obstruct and get in the way only until the energy gets above a certain amount and then start letting it through. It's like it was letting it to ground or whatever. So you're causing the magnetic flux to basically let go and move a lot more easily once you've gone beyond what the diodes need in order to function. And there is one more thing, which is part of what the, here, I'll scribble this out here. A inductor, like these transformer windings, is drawn as a sort of loop or squiggle. This represents the windings going around and around. If you have a capacitor and an inductor connected in series like this, they're connected to each other, so any signal has to go through both of them, what you get is a resonant peak. And this is how the gyraff does some of its stuff. I'm not doing this with mine, mind you, but there is still a resonant peak that has to do with just the fact that the transformer itself is a coil. So if you put a capacitor in there, it will have a effect on the transformer. And this is why the gyraff unit is worth $3,000. Is they worked out how to do things like, okay, connecting this or flipping this switch means it's engaging the low frequencies or the low mids and opening that stuff up. But I will show you now how my Magneto-Dynamic Infundibulator is wired with this little video clip showing the actual unit that I used. I have constructed a Magneto-Dynamic Infundibulator. Good day to you. So as you can see, I've taken a transformer much like this one with 3 wires going through it, 3 taps. And 2 of them had the crossed diodes. And then the third winding used both the diode clipper setup and a tiny capacitor. What I'm using is, I think, either 680 picofarads or 1,000 picofarads. It's a very small capacitor. And as such, it's lifting the high frequencies and also probably interacting with the diodes. But it's doing it in a pretty subtle way, just on the sort of fringes of the output. Now, one important thing to remember about this, if you try to use a transformer like this for your full output, and you just ran the entire signal through a coil and then picked the output off of another coil, certain things are going to be absolutely terrible. It will saturate the core, and so you'll get distortion out of that. It will fail to do bass very quickly because this is a tiny little thing. The tinier the transformer, the more it's going to fail to convey bass. Bass is just going to drop off when you're running through a transformer normally. This doesn't follow the same rules at all. It follows many of the rules because we're running signal through two of the coils, and the inductance is kicking in and causing the magnetic qualities of the transformer to get involved and even drive this other coil enough to distort diodes across it. But when you get down to the very lowest frequencies, this is a few hundred ohms direct connection. So when you build a Magneto-Dynamic Infundibulator, it doesn't eat base even if you use a tiny transformer, which I've done in the one that I showed. And the reason is because we're not using the transformer to convey the base. We're using straight wires to convey the base. And again, what we've got on the result of that is, I'll go back to this demonstrating of the audio. And we've got straight signal with just XLR cables. Then the base is not nearly as eaten up as it would be if we were trying to run the whole signal through the transformer using magnetic coupling to do it. It would never be able to keep up with what's being asked, but since we're using straight wires through the transformer, you can have a very extended base out of this little sucker, and it'll do its magnetic stuff on other areas of the frequencies. Essentially, you're just coloring it, but you're using straight wires. This is a cable. It's an elaborate cable. You're going in here, and we're going out here. If you unwound all the windings, you'd have probably, I don't know, 60, 100, a couple of 100 feet of very thin wire. And it would start in one place and go 100 feet away to another place and stop. So this is a long, long cable that's wound up onto a magnetic core. And for that reason, there's nothing to particularly fail us when we're trying to get actual base through, like here. And then the level matched. But of course, what fun is that? Functionally, what you can do with that is something kind of like this. Without, with. And then when everything is getting really busy, we'll look for this little peak here, and it's part of when I've got the that hi-hat going, which is causing that peak. Without the infundibulator, you've got this, and listen to the extreme highs and listen to the bass. Oh, I've got it on only one channel. Actually, I can do that here. Listen to the highs. And again, overall, what we've got is more like this. So this is the amplitude we can get out using just raw output. And here's where we're at using the Magneto-Dynamic Infundibulator. Build your own Magneto-Dynamic Infundibulator today. Or if not today, at some point. The point being, this is very much a starving artist sound engineer trick. You can't have a real giraffe Magneto-Dynamic Infundibulum. I can't either. I'm nowhere near being able to afford a thing like that. It is like diamonds and gold. It costs many times more than my car, and is a very cool thing with its own special transformers that are wound and all of this little balancing. Every little detail is handcrafted to produce a mastering engineer type thing. This is probably $2. You just heard what it can do. Be willing to experiment with audio circuitry, wiring, and stuff like that, especially if you're doing something involving, an analog mixdown or whatever. Because my whole point in doing this, I recently got a nice little mixing board. It's a Roland. I am happy as a clam with that thing. It's great fun. And having got it, I was running the output of it, which is XLR, into spare channels on my Motu converter. It's a Motu 16A. It doesn't have any microphone inputs or anything like that. It's just line. And I was very pleased with the sound, but I've been feeling like I needed to get something like a compressor or something along those lines, just so that I can condition the sound a little bit. Now, I'd like to be able to also monitor through that, but my outputs are a different setup entirely. Not that I couldn't take outputs by splitting the XLR to, but I'm also using the outputs for just, I'm using it as a sort of mastering console and listening through it, and I'm using the first aux return for tracks 1 and 2, which the computer will tend to use as basically the way I'm using it is my tracks 1 and 2, which is also the main stereo mix out and what programs like this one use, are on an aux return, so they don't have to run through EQs. And then my drum mix, which is input channels 1, 2, 3, 4, and so on, 5 for a dedicated kick drum mic, which I've done another video about. Those are actually going to outputs 2, 3, 4, 5, 6, and so on, even though the inputs are 1, 2, 3, 4, and so on. And then I'm running them to the mixer through channels 1, 2, 3, 4, and so on. So what I get from that is as follows. My real outputs 1 and 2 are always going to an aux return. I'm using them for reverbs in actual mix, and in normal computer use, I'm using them as my main outputs. Everything else is going into channels so that they can be equalized. I can slam them into the board if I want some of that old school techno. You're hearing that on this music, by the way. This Zoxbox sound. That's the sound of the Roland distorting. It's not bad. It's a nice piece. But the reverb that you just heard is coming in the aux return. And I'm probably going to design a plugin that's kind of like airwindows console, but dedicated for mixing reverbs, just so that I can run all of my reverbs to that aux return and use them that way. But I wanted to have something that would soak up some of the energy nice and cleanly, a compressor or something along those lines, to do mixdowns through. Hence the Magneto-Dynamic Infundibulator. And I'm very pleased with the result. If you're doing anything like this, if you have a multi-channel mixer, or even, excuse me, I've been sick all winter. I'm still trying to get well. Or even if you're recording tracks in and trying to condition them on the way in, you might want to build one of these things. You can build them into a cable. That's what I did with mine, is took an XLR cable and just cut the wire, and as you saw, I built that in there. If you have really small transformers, you might be able to build one into something like this. You could buy line isolators and stuff like this. If you take these guys apart, there's just a sort of H-pad of resistors in here, and there's a little space. It's not enough space to have a transformer that's this big. This one won't fit. The one that I used might possibly fit, and if you find even smaller ones, the action, probably the frequencies of the infibulator will go up in frequency, and it'll be voiced a little higher, and will probably engage a little quicker at lower volume levels, and might possibly fit into a pad box like this. So it's really kind of up to you. The challenges of getting this type of device are usually the enclosure, which is why it would be neat if you can come up with a way of doing it inside a box of this nature, because you can buy these fairly cheaply, just like you can buy cables fairly cheaply. If you have to buy a Hammond aluminum box and real XLR jacks, those get more and more expensive, by which I mean on the order of like $6-8 or something for a really nice one. Something like this, a little plastic guy that connects into something, might be as low as $1 or $2. And buying an XLR cable, it comes with the connectors you want. So you will basically end with a cable with a weird lump in the middle that's covered with electrical tape and maybe tinfoil or something. But you can build these things. It's important to be able to take care of yourself and build stuff like this, so that, well, my concern about where the industry is going is it seems to be going in this direction of increasingly fewer companies selling things that are really just kind of rented to you and you don't get to keep, and also force you to update your computers and everything every step of the way. And I'm not a big fan of that scenario. So what I'm doing with airwindows and also with the Patreon and such is trying to give people tools and advice for being able to build their own stuff and take care of their own needs in this way. Now, I encourage people to go out and buy the Gyraf Audio, I think it is G21, Magneto-Dynamic Infundibulator, if you have a spare $3,000 lying around. Sadly, I don't. Very possibly you don't either. And I'm real sad about that. But never let something like that stop you from building a perhaps lesser, weaker version of the thing and getting a similar reaction. It's like if you can't buy a Les Paul Gold Top, you buy something from Ibanez or whatever, and you play your musical notes on it. And the important thing is access to the tools and being able to do that. And your result can take you from here to here.